Okay, so yeah, welcome everyone to our new web series for this year. Alex and myself, we have preparing a new web series which we call Preparation Training for LPIC-303, the security part. So this is going to be the topic of this web series. Today we are going to talk about a specific topic. Nevertheless, let me introduce you to the agenda or what we want to do in general together in this series. So what is our goal actually in this webinar series? So we have two goals. One is preparing for the training for LPIC-303. So anyone that is interested or is preparing to get certified for the LPIC-303, we are going to discuss all the topics that usually are asked in those exams well, within that, of course, our goal is to share the knowledge. So it's what we are actually also learning from ourselves, from our daily business, or just from as a hobby on the side. We would like to share that knowledge, but focusing on the LPIC-303. So what are the considered security areas? We put them here. Which is cryptography, host security, access control, and network security. Nevertheless, this you can find more information in this page. So I'm going to share with you. So I'm going to jump to the other view. So here, if you go to this side or to this URL, you just Google LPIC-303 exam objectives. You will find this this page, and as you see. There are these four main topics here. So we have cryptography, host security, access control, and network security. So Alex and I, as we also fully work on other stuff internally on projects with clients, and in addition to that other stuff, so we decided not to follow a very strict path on this agenda. So we are not going either top down or bottom up. Nevertheless, we are picking one of these topics, the ones that we feel more comfortable and we have the time to prepare it. Then we will discuss this topic. Nevertheless, our goal is that at the end of this webinar series, we have discussed and we have addressed all of these topics and have gone through this list. So if you start by cryptography, you talk about certificates and public key infrastructure or certificates, encryption, sign-in authentication, and so on and so forth. So you can follow this topic and we will make this clear. So each topic for the session that we are going to discuss is going to be available. It's going to be public so that you are able to join if this is a topic of your interest or if this is a topic where you feel yourself very comfortable with and you don't need to join on that day. However, these webinar series are going to be recorded, so you have the chance to listen to them anytime when you feel like it, or maybe even just go back on one of the topics and you want to, yeah, let's say replicate that, or you want just to dig a little bit more or understand a little bit more about the topic.
Yeah, and
yep.
As we had it with the agenda, we're also not going to start with cryptography right now, but we're going to start with host security. And yeah, well, like we're going to go through at our more or less own pace. I think right now it more or less seems for us that it would probably be like every month one, if I remember correctly. And yeah, I said like we're going over the topics, but we're going over them as more or less we see fit, and like we also have more or less learned or looked into them. Yeah.
Exactly. So this is going to be our kind of methodology in how we work on the topics. Today we would like to talk about host security and host hardening. And as you see here in each and every topic, there are subtopics, or let's say areas that are considered important for that. And you'll find this on that web page. So we are not going to do anything more than what is asked for this exam. So it's actually keeping on these topics because this is going to be asked on that exam. This is going to be the content. Nevertheless, we might discuss other topics of interest, or in the discussion round after each session, and we might have different conversation, not focus on that specifically, but as we go into the session, we will prepare all of these topics. And yeah, today, as you see, we have or under host hardening and host security, you'll find these 7 topics, and we are going to talk today about the four first ones. So configuring the BIOS and the bootloader, the kernel, disabling useless software and services, and so on and so forth. So the 3 other ones that are part of this topic are going to be discussed in the next session, and so we'll continue and address all the topics one after the other. Yes, so anything else maybe from your side, Alex, or
I don't think so.
Anything?
I would say let's start with the first part, which would be configure our BIOS UEFI.
Yeah, so let's start with the first part. Well, before we go into the topic of BIOS or the bootloader, it's important to understand, or from a security perspective, it's important to understand where actually we are, or at what layer we are talking about. So here in this very simple diagram, so you will see the booting process, starting from power on to making some power on self-test. And then you have the BIOS, which is the first, let's say, piece of software that is started on your machine. From that, it looks about, it searches for bootable devices, it finds the bootable device, and then with the master boot recorder, which is then the one where you find the bootloader. And the bootloader loads the operating system, and so on and so forth. So the kernel is loaded on memory, and the services, the system services are also started, and also user processes are started. Why is this important from a security perspective? So let's assume, for example, we are going to talk about the bootloader and what you can do with the bootloader. But this is something that if you have, let's assume, physical access on the machine, and you would be able to insert a USB stick on the machine, which has a bootable device, or you can have a network from the network perspective, then everything we do after this step, meaning from the bootloader and down the path, it's not going to help us to secure the system. So it's not going to help us to harden the host. That is why it is important at this stage to understand where actually or what are we talking about. Usually, if we talk about a bootloader and we make sure that the bootloader is the authentic one, then you can make sure that you don't have, let's say, a kind of rootkits, right? So, but if you don't have a secure boot, which we are going to talk about in the next slide, you would be able to mitigate bootkits. So this is what, let's say, the main attacks, or the most difficult attacks that you want to address while hardening your host. So configure the BIOS and the bootloader. Well, for the BIOS itself, so I haven't had any, let's say, I'm not going to do any practical example on how you can actually secure your Wi-Fi unified extended firmware. There's plenty of literature how you do this, and if there is interest, we can prepare a practical example or a small demonstration maybe in the next session. Nevertheless, what I still want to introduce here and I want to talk about is the secure boot process. And the components or the process itself, why the secure boot is important. So the secure boot process actually is based on the, let's say, is establishing a chain of trust, right? So, and this chain of trust is based on the platform, is based on the root, and is based on public key cryptography. So you have public key pair, which is part of your chip. It is put there from your device manufacturer or the original manufacturer of the device. And from there, you start, you put the trust on that, and you create a trust of the chain of trust. What are the keys that you have in there? So you will have on your left side, so you have the let's say the private keys, and you have the Wi-Fi firmware. And the most important keys are the key exchange key and the platform key. So the key exchange key, it allows you to create a platform key. So you can have only one platform key, or let's say this is one key that the identity of the platform with which you can now test. On the one side, you can test that the platform is starting in a secure, in a previously secured state. And you can also attestate this to remote parties. So you can do this from remote and make sure and measure that your system actually is running in a secure state, in a state that you have previously configured, or you have previously agreed that this is secure. Another thing that is here important is the other keys, which are kind of the databases within the Wi-Fi certificate storage, where you have those that are allowed to start and to boot those systems, let's say system drivers or the bootloader that has been signed. So all of these software components that start after the firmware have started, as we saw before in the process, needs to be signed and need to be verified. And those that maybe are malicious, that are already identified as being malicious, of having backdoors, which is the DBX. So the process you can find on the middle. So you usually have the same what we had on the first stage, but a little bit more simplified. But here it describes you the steps that it usually goes through. So what you do, so you initialize the firmware, and then it reads the bootloader, and it computes the hash of that bootloader, and it verifies whether that bootloader has been manipulated in some way, right? And if the hash of it is in the DBX database, meaning that has been known as let's say a bootloader that has been tampered with, and something that is malicious, and it brings the system in malicious states, then the system doesn't start. And if this is signed and the signature is correct, you run the system. So you continue running, and then the bootloader, and then the drivers, and so on and so forth. So this is kind of each of the systems. So you delegate the trust of chain. So the bootloader now verifies the drivers' signatures, and if these are correct, then it starts the drivers. The difference, what you have here, what is important from the Linux world perspective, is that usually the bootloader is signed by a specific party which you have to trust, and it's usually signed by Microsoft CA. So if you want to, let's say, to load the bootloader, which is a Linux bootloader, so you'd need to sign that from Microsoft. But you can imagine that there is not such a business case that you send bootloaders anytime you want to start a new system or a secured system, and they are going to provide you a signed system. So that is why this concept of the shim exists, which is actually, again, an intermediate bootloader that is signed by Microsoft. And with that, you can then sign your bootloader from that. And so you can start any system so that you have some intermediate step in between. And this allows you to have also secure booting under Linux operating systems. Yeah, so this is what I wanted to tell about the Wi-Fi and the secure boot process. If there are any questions already to this topic or any ideas or you want to discuss further, or Alex, from your side, maybe any additional comments on that?
Well, at least to anyone not knowing the reason why some people were initially more or less against Wi-Fi on the Linux side, like with the certificates there. There we have it. There you have it.
Yeah, so, but still it's, of course, if you have very critical systems that you need to secure, then there are ways to do this and to build this chain of trust from the hardware and make sure that your system is running in a secure state. It's not that easy to do. It's not like you can do this in a very easy way. So you need to do some steps, and this is probably a little bit cumbersome. Nevertheless, it needs to be done in highly secure, highly critical system environments. Yeah. So
at least thinking about it, I think something like this, like creating special hardware, so to say, would probably make sense for like secret stores such as Vault, where like the big roots secrets, so to say, or well, certificates or something is in. If you really want to make sure that, well, no bad entity could do anything bad. So.
Yeah, so this is a good point, and from a practical perspective, this is also being used from the, let's say, the HSMs kind of, or maybe not HSMs, but I would say key management systems, which are built. Which rely on, let's say, a general purpose operating system as Linux. Of course, a very small print foot of the Linux operating system, a very tailored one. Nevertheless, they do use two key technologies. One is the Trusted Platform Module chip, which is what we say here, the secure boot, and the other one is the kind of trusted execution environments, which also the chip infrastructure. So let's say that the major one, Intel or AMD, do support for running your secrets or storing your secrets and executing very sensitive operations like cryptographic operations, generating the keys, sign-in, and so on and so forth. So it's exactly what you said. So even in practice, this is exactly one of the areas where this is being used practically. Yeah. Okay, so let's go to the next topic, which is the GRUB version 2. So what you can do in the GRUB version 2 is actually you can have a password protection. Meaning that you are able to say that who can modify, well, let's say the system that you are booting from your hardware, and we are saying that, of course, here you need some access into the system, right? So we are assuming that you have access to the system, and you want to prevent that anyone can load your operating system. So imagine on hardware, what you could share, maybe you have different operating system running on that, and you want to have those separated for, let's say, different users, and you don't want anyone to get into your system. You can protect even from the loading entry with a password. What you can do from the GRUB version, so you can have a global or OS-specific password, meaning that you can say, well, I have, I do block with a password entry all the GRUB, all the entries, so you cannot modify them without having, without knowing this password, or for a specific operating system. You can store this as encrypted or unencrypted, and I'll go to this here, so you can configure how you can configure. So you find the configuration files under etc-grub.d. So let me maybe go to the machine. So let me show you how it looks like. Okay, so we have to wait a little bit. My machine is not that fast.
Yeah.
So it needs to wake up. Okay. Okay, so now I think it's.
Oh, it seems like your VM is stuck for some reason. Oh, well, maybe just continuing on those points, like even with like a password or something on the GRUB, like the risk, like especially with like more or less corporate companies, to put it like that, where you have, well, you still have hardware. Like I'm personally myself more or less a hardware server fan instead of just everything cloud servers necessarily. Is that there's a reason why the servers are in a data center, which is then secured by biometric scanner things to secure the entrance to the servers. Because, well, if you have physical access, well, the only really thing you can do is encrypt the data, for example, on a machine. Like there's not really too much a point necessarily with like having a password in GRUB or something, if you would just be able then to prevent like something else to run also. But if I have physical access to a server, most of these points where the protection would then, well, would be able to prevent anything would more or less just fall flat. Because if there's like, let's say the disk is unencrypted, I would just go ahead and put in my own disk with some malicious code or something. Like that's the thing that still needs to be kept in mind. It's not just, you can't fix everything in software, to put it like that. And now let's see, maybe the VM is starting out. So just more or less a point to watch out there again. Like if you have your servers all across the globe, to put it like that, and every server is unsecured, like technically anyone could access it, access the server. To put it like that, you're gonna have a bad day. And well, there was an interesting DEF CON talk, which I was sadly only able to watch on YouTube. Was that there was a person which put it a simple: if your server is labeled Exchange server or something, and then he held up like a USB stick and was like, and this USB stick is sticking in this machine. you're probably not going to be able to have your mails you're not going to be able to read your mails anymore or something. And that's the basic case. Like it's in the end, if I can access the servers, I can do a lot of fun things. Like even if it's encrypted, like if I have physical access to the disk, I could, well, try to do some hacking and, you know, do some bad stuff with it, because I then have the time. And now your VM's working. But let's. Here we go. And yeah, so you can't fix everything in software. You should always also keep in mind that a lot of these things can already be covered to a certain extent by simply having like physical access restrictions in place. And from there, it more or less begins with like, where do you see the risk? Do you see the risk in a data center worker to do something bad, to put it like that? Do you expect them for like in big quotes for non-critical data unnecessarily? That it's fine that they can, with their access cards and like weight scanning or like retina scans or something, or fingerprints or something, that they are able to access the data center? Or or do you really have like some sensitive systems? Like I think certain companies where they maybe like where they manage certificates in certain ways, where they have different servers and then also different racks, which are secured, which are actually secured with like, how it's called, a 4i principle, where a person can only do anything in a rack when there's 2 people at the rack, because they need to enter some PIN or something, because the data is so sensitive. And it all depends on where you see the risk, more or less, also with those topics.
So here we are back again. So I wanted just to show you that where you can find this is you find all the slides. So you have this 01 user or 40 custom. So what you can do, actually, the users need to be added into this file. For example, if we just look into that, this is how it looks like, and here you need to enter your users. So here you say, for example, let's say here, for example, you would say, okay, so I need the password. You'd say for user, let's say lab, and then you enter the password, right? So you enter the password, let's say passvd. And as you can see here, there is a problem. So imagine now, as Alex was saying already, the physical access is something very important. So if someone has physical access into the server, is able to start from a live system, right? So he would be able to read the hard disk where your system is actually stored. Then he would be able to read this. Right, so he would be able to read this password in here and would be able to start your system. So and how you can prevent this? So I'm just getting rid of this. So I'm not storing it. How you can prevent this? And in the for custom, you should put the entries. So I'm not going into that. What is more important is exactly the group command, which is the make password, which you have a key derivative function, a public key derivation function for having actually the hash value. And what you can do with that is actually you can just call that system, and it asks you to enter a password, let's say whatever. I'm just typing something. Yeah, that is great. So and it gives you actually the hash value of the password you just created. So you would go back into that file which we just saw, you would not put, so if we open it again to see, so you would not put here a password, just password as I put before, but you would put really this keyword. So the password underscore public key derivation function 2, and then the user, and then paste that hash value that we just calculated with that function. So this is actually how you can do this for having a secure boot password and bootloader password, and not leaving it in the plain text. So, and especially what is important to remember here is exactly where and what you can do this stuff and how these commands are called. This is really for the LPIC-3. You really need some time to have these commands by memory. So you have sometimes to be able to recognize which actually was the right command. So that is why they are supposing that you work with that every day, and you are using those commands and you are using them in your everyday business actually. So that is why this is important in some at some stage. Okay, so let me go back. So what is the next topic? It's configuring the kernel. And the first topic in configuring the kernel is the Exec-Shield, or non-executable as it is called now. So it was called previously Exec-Shield, and you can also find it as an Exec-Shield in older systems, but for the moment is, or they've kind of agreed on non-executable. And what it does, it's a security mechanism that it protects you against, let's say, stack or buffer overflows. And this picture, which I borrowed from the Linux magazine, it shows this very clearly what it means actually. So what does this non-executable does? So on the left side, you see the process address space. So if you started a program and it will get a virtual address space from your operating system. And this is how it would look like. So it would have the data and the code which are mixed in this address space. And if someone identifies a vulnerability in your program, it can introduce code into that stack area where the program is being executed. Like, for example, how usually the most attacks work on memory, it will overwrite a return address, and that will jump into the code that has been introduced by the malicious attacker into that virtual space. The difference there is that if you use the non-executable function, you would be able to differentiate between data and code, meaning that some of the addresses or this virtual space is divided into code, which is something that you can only read on, so it's cannot be overwritten, and data, which is something that you can manipulate, but you cannot then execute as you can execute the code. So trying to introduce code into that address space, it will not work if you use this protection. So this is what it does. And here you can find out if this is being supported by your operating system. Well, really what is important is that these commands, I've always been told that you need to know that this command. So if this system is killing me,
you need to. I think you copied the command wrong.
I didn't copy it. Yes, it's true. I have to.
You're missing the /proxy view info there.
Yeah. So I need to see where actually he needs to look after it.
/proc/CPU info. And then we got it.
Yeah, okay. So here we see that the architecture is actually supporting that. So this is what you can check if it is supported, and to see if this is actually it is actually activated, then you need to look at your kernel. Yeah, so you see that it is executed, the execute disable is active, and this is actually by default in most modern operating systems. So it's something that, well, you can sit down and relax. This doesn't mean that your system is secure or hardened in each and every perspective. Nevertheless, from those kind of attacks, you would have this security mechanism, which is in there by default. What else? So the next one is ASLR, which is address space layout randomization. And again, it goes in the same direction as the non-executable, but from a different perspective. So what it does, so you need to think of these mechanisms as something that can be complementary. So they are making the system stronger in itself. So you cannot think about it. If I use the non-executable and I don't use the ASLR, I'm secure. So both of them provide a specific perspective on different attack methods. So assume that the non-executable has been, let's say, has been mitigated, or there is a known exploitation how to avoid or how to mitigate or how to circumvent that. You would have the SLR making the effort from an attacker perspective a little bit more difficult. So this picture again, it shows what it happens. So for example, if you have a process that is started and all the executable or the stack, so these are going to be always in different address space. So if an attacker is, let's say, especially with attacks which are called random oriented programming, this is, let's say, a class of attacks that it will circumvent the non-executable feature mechanism, but with the ASLR you make this more difficult for random oriented programming, because then a malicious attacker would need to guess where he finds a specific word or a specific command. Yeah, so, and just to, because we need also to think about the time a little bit. So if you see here, if I load the bin bash and if I load it again, you will see that this program is being actually started in different addresses in memory. So this is what it does, and these are by random, meaning that if an attacker needs to have access to it, it needs to find out where actually this has been started in memory. Yeah, so then I think this is, so these are some commands that, yeah, what is most important here, of course, it's that application needs to be compiled to support that, right? So when you compile applications, so this is a very important point. If you have an application and you have not compiled it with supporting this with the platform independent execution, then this is not going to be supported, even though this is active on your system, right? So this need to be active on your system and need also to be supported by the application. So the application needs to be aware of that. So this is it. The next topic is IP. Well, I put it just here as a kind of side comment. IP version 6, if you are not using it, you should disable it. That Alex will say something about disabling useless software or useless services in general. So this is
well, IPv6 isn't useless, but
I'm just saying in general. So if you have something that you are not using, you should disable it.
If you differently put, if you're still one of those, yeah, NAT is great, woo, feel free to disable it. Otherwise, at least from my security standpoint, using something like IPv6 makes your life from security side easier because you have, well, one address and not traffic comes in with this and needs to go somewhere with some private IP here, and you need to make the connection between all of them in the end when you need to find the issues. But well, yes, we can argue about that.
In general, what you can do, so if you use IP version 4 and you want to kind of prevent spoofing attacks, so you have the reverse path filter option. In addition, so what you can do, it's actually, it has the reverse path filter option. It provides you the ability to prevent data or spoofing IP. So it provides it prevents the accepting information and connections from systems that actually are not within your network, or they are trying to spoof addresses. And especially this helps also against preventing DOS attacks, because imagine so a system that is getting connections from spoofed addresses and is trying to and is waiting to do the TCP handshake and is waiting for any response. If those addresses have been spoofed, those responses are never coming back. So then, and your system at some point in time, it's not going to be able to have any TCP connections. So that is why actually it's very important to have this activated.
Maybe just for anyone having issues with their container networking, depending on which which CNI container network interface you are using. I think with Cilium, because of systemd version 245 or something, they changed the default of the RP filter and basically broke the whole networking with Cilium and such. So just FYI, like, yeah, you should change it, but at least for something like CNI, I think a good setting was, I think, 1 and not 2. I think 2 was much more aggressive, and at least I think there's a whole issue at Cilium, at least of where they get scrubbed. I think it was 2 breaks it and 1 is fine, which prevents the external attacks. Yes, just so FYI, because I think they had like 8 hours trying to figure out what the issue was.
You have the three values. So 0, it means that is disabled. It means that it allows probably spoof packets. 1 is the let's say the most strict one, meaning that it doesn't allow packets to come in from a different address or from in a NIC where actually they are not being expected. It's not going to forward this to the right NIC. And the 2 is actually allowing asymmetric connections, so asymmetric routing. So probably they use 1 and they probably should have used 2, meaning that they should have been allowing the asymmetric routing, meaning that it goes in 1 NIC, but it's then going to be forwarded to the right NIC, which is again within the same machine. Which I assume this is probably, this has been the issue. So I'm assuming no. Yeah, so, well, here you find the commands and as I said, so this is what you need, and Alex put it from a practical perspective, what are the different values and what can be the issues with that, which is a very good addition. The last topic is the ICMP, and Well, what you can do with the ICMP, so, well, this can be used for host discovery, and a very easy way to do host discovery, it's like, for example, pinging the broadcast of your network. So, for example, you are in very small network or private network, you can broadcast, and each system that is in that it will send you back. So you would need to
you want to block that. You definitely want, or like if you have good reasons to not block it, but normally you want to block things like that, as it will normally like cause more issues, even in a small network. Like even, you know, we're just talking about small ping packets, but we're still, let's say you have like even just a /24, so 200, I'm probably gonna say something wrong here, 253 or 254 hosts basically. And if all of them then go like here, ping packet, it's not much, but it's still traffic that you don't need, because if someone does it like every millisecond, let's put it stupidly high, as an example, then you still have a bunch of traffic which isn't needed that's going on. So the next thing you really wanted to say is exactly, you can turn it off.
Yes, so you turn it off, and as Alex said, it's put it very well. So we have here two security goals that actually are in place. So one is what is about availability. So then your network is going to be not available if everyone is busy with responding to those broadcasts. And on the other hand, you want to keep your system obscure, meaning that they shouldn't respond to traffic that is actually meant for everyone else. So they should respond to traffic that actually is meant to those systems.
Yeah, like, but just as for SMP in general, they're more or less, you can always argue if, like, I hope my apprenticeship lead will not see this, the recording of this, what I'm about to say, but at least I'm more one of the people that says, hey, okay, I'm fine with ICMP, or at least like the echo, so no ping packet, but only like 10 per second, because if I get more than 10 per second, why do I get more than 10? But then again, this can make debugging of problems in network related stuff very, very hard. And to just maybe more or less throw some, well, to put like that real world information in here, at least with an interesting fact that maybe it was obvious to everyone, but at least not to me, that I had someone having some issues with a machine at Hetzner, and I was like, yeah, sure, I'll take a look. And I was like, yeah, network is weird, no. And I run an MTR, so basically a trace route to it, like a constant trace route, MTR. And I had, like, even for some MTRs, it's done like 80–90% of package loss at, let me not say anything wrong, just one hop before the switch where the machine is connected. And I was like, it can't be, is there something wrong on there? And like, hey, we went ahead, created a ticket, and the response was like, yeah, well, the routers are configured to only reply to ping packets if they have computing capacity available. And at least for me, as it maybe I just didn't know it, but to me that was news, because I normally expect a router, or well, ironically, even though I limited to like 10 pings or so on my machines, I normally expect the machines to at least respond to a ping once in a while, and not like have a bunch of loss which isn't there because the trace route is simply dropped. But a bit of a wide excursion here, just as.
Yeah, so it's great. So
well, good tool to diagnose network issues. Okay.
So you want to say then, just continue and say something about.
I'll gladly continue because I have another thing. Could you go once further?
Sure.
When you get such an email, it goes on a bit further, but if you get such an email, you did it, to put it like that. Oh, well, you did it, right. how should I put it? I think we get these emails from time to time when we have like new servers or like we reinstall systems, and like, you know, you're not getting to it instantly or something. Like, let's say there's a few days in between, and from time to time we got emails then saying, hey, you have servers with RPC or like PertMap or similar services on the machine, and these services are at least during an install, at least for some OSs, by default active to, well, like mounting some network file systems or something. And exactly as the last 3 lines there say, over the past month, systems responding to port mapper requests from anywhere on the internet have been increasingly abused DDoS reflection attacks against third parties. And this email is just like the nice, hey, please take a look into it. There's no consequence, but please look into it, basically. But this is exactly one of the reasons where it comes into play of making sure the default configuration is right. Could you go one further?
Sure. Because,
well, we got this email, so we know something's up. They even mentioned a service, so we can assume port mapper, whatever service is going on this port, 111, I think, if I remember. One further. So some default services can be bad if they are left unprotected. Like, technically speaking, SSH, if you just install it, is also just a default service running on the system, which is unprotected in quotes. Like you use SSH key, so it is kind of protected. But there might be some other services which are simply left running or are installed for whatever reason by the OS, which keep running and might be a backdoor. Like, not necessarily saying like that is an issue as a software, but just to like give you a grasp on that. For example, with like Fedora, depending on which edition you install of Fedora, they install the so-called cockpit software. So you not only have an SSH server running, but you have the web server. I mean, big quotes. It's more or less like a daemon with which you can control a server. This interface, it is password protected. I think it is even by default, like, I don't know, some way key protected or something. The point though is, it is an additional service which runs on your machine, which has a port open to the public. And it uses HTTPS by default, which is great. But if you think back to some things like Heartbleed, or was it Heartbleed?
Yeah.
Like there's all those super cool, yeah, I got to patch my systems in the next 24 hours before the bug is released kind of issues with OpenSSL or LibreSSL or whatever SSL you're using there. It is cool to only have those things, publicly or just in general exposed, that you know of and that you take care of as well. Because if you have something like Cockpit Open and you don't know about it, and there's a security issue for whatever reason, and you don't know about that, you're gonna have a bad time at some point, especially if those systems are publicly available. Yeah. So for publicly exposed servers, just as a more or less a thing for consideration, I know a few people which don't change the SSH port from default 22 to something else. Even for public servers, for internal servers, you normally don't want to change that because you just keep 22. There's no one that should attack the port. But at least if you have a server publicly in the internet, it's a good idea normally to change the SSH port to something else than 22. Because otherwise, like, even if, well, you can't really say a new IP, but even if you just install a system and there's not even web server or anything running, I can guarantee that every bad person at one point will come knocking on your SSH port and say, hey, it's me, root, can I do something? Permission denied. Well, I tried. Thing is, it's not like it. We can definitely argue if it makes more sense to change the SSH port or just like increase certain security protections, use fail to ban or something to automatically block bad people attacking or something. In the end, the thing is simply, it's a port that is exposed. And especially, at least for SSH, from my personal opinion, I think most people share the same opinion. If it's a public server, change the SSH port to something different.
Yeah, so it makes totally sense to do that, because just imagine, so if someone is not targeting you specifically, right? It's
targeting, they will find you. They will at least find you. Yep.
Yeah. So if it's 22, then they will find you. They will find that this server is listening on 22, and maybe then in the next step you become a specific target. Whether if you have it on another port, you would escape that kind of attack, like trying to avoid becoming a target.
Yep, and at least even like, let me put it like this. I haven't experienced DDoS attacks like Cloudflare with like terabits, or even, I think not even necessarily gigabits, big of a few gigabits per second or something. But let me try to, maybe I'm able to quickly find the picture. But would you mind maybe quickly opening this link in your browser, just in full screen, that the URL is not visible? Maybe just save the image and open it then, like so that the image is only shown. That would be cool. Yeah, here we go. Yeah, that's it. This, you know, like this was definitely a targeted attack, but still. Point being, you're on the internet, you're publicly reachable, you will, worst case, get screwed like you never wanted to be screwed, or you just try to stay a bit hidden, to put it like that. I said, like, this is for HTTP, point being, there's always some bad people which want to do bad things. That's why I'm more or less message here with the changing ports or something. Because as just last point here, if you install a new machine at DigitalOcean, at Azure, at Hetzner, at whatever cloud provider, and you, let's say, wait like a day or two to connect to the machine with your, hopefully then SSH key, not password, bad, you will probably get a login message that says something like, welcome user so-and-so on. Welcome user so-and-so on, and then the next thing would be like so-and-so on many failed attempts for login. And this is depending on how lucky you are, just a few 10 or 100 of, if in the worst case, thousands. I think that someone like, yeah, my machine feels slow and like the disk is running from, like, did you check like your machine, where's the usage coming from? And it was before systemd was cool. And I think there was like the auth log of this machine was like a few gigabytes full. I was like, what is going on? Just because there were so many bad people trying to connect to the machine, or like bad bots. In most cases, it's just automatic bots, but there's someone always normally behind those bots. So, yeah. Okay, let's go back to the presentation.
Next topic.
Let's talk about limiting resources. I'm more or less trying to be a bit short on this topic here, because it's more or less the question of, like, you should know what it does. You should know that it exists and what each of these methods can limit. And there's definitely also other ways to like limit certain things. But the thing is, your limits is basically a way to limit kernel-based resources, like how many files can my process, or well, a process open, how many sockets can my process open, and so things, which, well, is files in here. So again, back to the files there. And for C groups, it's basically limiting host resources, meaning you can limit the CPU time, memory, network bandwidth, and even I/O. Though for I/O the nodes, I think that was only really feasible in C Group's version 2. Yeah, but so just keep in mind, for your limits, it's everything kernel based, which can be limited for that, and C Groups, everything host related. So resources like CPU, memory, network, I/O. Yeah.
So that we are at the end of this first presentation. So a little bit, we're exactly on time. If we started at 4:30, so we started 4:32. It's 5:32. We plan to have some time for discussion. Nevertheless, we'll stay here longer if you have any questions. So you are welcome, or any suggestions from your side.
If you
yes.
Oh, there was a question regarding why not use fail to ban. Well, you can use fail to ban, but you still basically, at least from my perspective, let's just put it like that, you still have the resources going into even having connections being established with your SSH. Even that's very optimized, but still there's resources flowing into that, even if it's just a little bit. And then fail to ban analyzing the logs, which also isn't a lot of resources which is used for that, but it's still, well, something that is then also running on the system, which you need to take care of. Like, use it like I'm using it too, or I like it, but, well, yeah.
Yeah, so of course, I mean, you can use it as Alex said it, input it. So there are many other tools that you can use from a security perspective, for sure. But these tools are, let's say, we are focusing on those topics that you can do from the operating system perspective itself, which are not, let's say, tools installed additionally on the operating system. So this is something. And of course, this is a good information. So please always put into your suggestions and comments. So always welcome. I just wanted to make the point that we are focusing on those topics that are asked in this LPIC-303 exams, and topics that you would find within the operating system itself, and not additional software or additional mechanisms that you can install on top of that, or yeah. So that is just the point. But yeah, it's a very good good question. It's a very good suggestion.
Yeah, like but I said, like nothing against fail to ban. It's just more or less the. Yeah, it works out of the box with SSH, but do I really need fail to ban a bunch of IPs which try to log in as root for 2 times or so, and then I've banned them? And it's a peace of mind, more or less thing. Like I use it as well, but well. It's fine. It's doing its job.
Yeah, so are there any other questions to the topics we discussed today? Anything else that is of interest and you would like maybe to see? This is a small demo or showing how this is done on the level of the operating system itself.
Yeah, feel free to leave any, like, I'm not sure if our emails are at the meetup thing description there, but feel free to reach out to us with any feedback or any like topic recommendations there regarding LPIC LPIC. Yeah. Yep.
Cool. So then, yeah.
Thanks for the question, and then.
Thanks for your attention. We call it for the day. Thank you very much for being here and attending, and hope to see you next time, and the topic that we will select is going to be announced as soon as possible for which topic is going to be the next one that, well, we have these 3 topics that we already have in here, so we will continue with those 3 topics for sure. But maybe we can even add another new topic on that, but I cannot promise to you now. But
we'll see.
What we have already is the 3 that we left from the host hardening topic. Okay, thank you. Have a nice day. Bye-bye.
Nice day. Oh, wait, there was one more chat message. Is it? Oh, yeah. Thanks.
Bye-bye.
Bye.